All right, I'm back to basically show you how to do the first steps of ArcHydroTools, which will allow us to map the drainages within the Spanish Fork River watershed. We won't quite get to the level of defining the boundaries of the watershed with this part 2 video, but we'll get to that in part 3. So the steps are going to be that we're going to kind of prepare the watershed DEM to map channels. And we'll get to the kind of point of almost mapping channels. Okay, so let me share my video. Again, I'll be showing you both ArcPro and ArcMap. So on the left is ArcMap and on the right is ArcPro, and we have our central Utah DEMs there in both cases. So I'll show you what we need to do. Basically, there's 3 steps. First, we have to fill the DEM. And the reason for that is we're going to map channels through the landscape. If there's internally drained areas within the DEM, i.e. holes, the process to get a channel through the landscape doesn't consider hydraulic gradient and pressure of water, so it won't keep flowing based upon the way we calculate it. So we need to basically smooth the DEM and get rid of holes. And within the Arc toolbox here, we have hydrology tools, and it's called, it's under spatial analyst tools, the hydrology toolbox. Within that, it's called fill. So if you click fill, a dialog box will open up, and we input the central Utah DEM, and we're going to create an output surface raster, which I'm going to call fill DEM dot. I'm going to do 1 in this case because I'm going to do this twice, .tiff. Okay, fill DEM 1.tiff. Start. Save, and that is it. Continue. Okay, so to do the same thing over here, we just go to the analysis tools and search fill. It's in spatial analyst tools as it should be. And so we do the same thing, CUDEM output can be to the same place. And in this case, I'll call it fill DEM2.tiff and run it. Okay, so on the left, the ArcMap project has already finished. We'll see the DEM is broadly the same. And we need to use that in the next steps of the process. And so the next steps of the process are essentially to calculate the direction that if water falls on a pixel in this digital elevation model, where will it flow? And so essentially that's called a flow direction raster. So that's the 4th one down here in the hydrology tools. And flow direction is kind of like aspect, but it's not coded in the same way an aspect map is coded. It's coded by its neighboring pixels as instead of 360 degrees. So we will go ahead and do that. Both data sets have finished. So if we click flow direction over here in ArcMap, dialog box opens up. The surface that we want to input is the fill DEM. And we will then create a flow D.tiff, D1.tiff for me, flow direction. And there's the drop raster and flow direction type. Just leave that stuff alone. We're not worried about the edges of the cells, so we don't have to worry about that either. Let's just go ahead and say fill DEM and create a flow direction raster. And then over here, we have to go to Tools and look for Flow Direction. And we input that fill DEM2, and we can create a flow d2.tiff. Flow direction 2, because I'm doing it a second time in my folder. Go ahead and run that. And so you should see now that on the left, ArcMap has completed what looks like an aspect map. You can see ridge lines outlined, flat lake, etc. Same thing here. It's finished over in ArcPro. After having done flow direction, the next step is to calculate accumulation of flow. And that will use the flow direction raster to determine for each pixel in the digital elevation model space, you'll create a new raster where the pixels have the value of how many other cells flow into them. So flow accumulation. Remember that these tools are in alphabetical order. So it's the third step is flow accumulation, even though it's not exactly in that position. So if we open up that flow accumulation tool, it asks for an input flow direction raster. So flow D1 is what I want. And I'm going to output that in my space. I'm going to call it flow ac1.tiff. So flow accumulation 1.tiff. Okay. And we'll leave all this as it is and say OK. And same thing over here. Go back to Tools. We can find it down here, flow accumulation, or you can type it in. So input my flow D2, navigate to my folder, and we'll call it flow ac2.tiff. So the process is the same with these two programs. Functionality is pretty similar. Might even be just as fast as one another. Because it's pretty easy for them to calculate, especially on this SRTM data set, which is pretty coarse at 30 meters, not very high res. Okay, so it's done on the left. On the right, it's still working. This process will take more time. So if you were doing this on LiDAR data over this huge area, it would take a long time to actually run this. But since we're using SRTM, it's going to be quick. Okay, it looks like a big black nothingness, because you can see how it's basically scaled itself for visibility here, where you have values ranging from 0 to 9 times 10 to the 6th. So that means that there's 9 million pixels that flow into some of the pixels. And you may or may not be able to see that those areas kind of create these really light areas in the image, and that actually is outlining the Jordan River, I believe. So why is this useful? Well, actually, we can basically go into the properties of this flow accumulation raster, and if we go to symbology, we can classify it. And we can just say we only want 2 classes, and one is river and one is not river. And so you can basically say the not river is no color, and if we were to classify it, where is the not river? So here our natural breaks are at 3 million and 9 million. But we'll say that there's river anywhere maybe more than 1,000 pixels. So I'm going to try that as a test. Okay, so then 0 to 1,000 is no color, but anything bigger than 1,000, we'll just keep all as one color, and I'm going to make it black. Okay, let's see what that looks. Okay, so we need to turn off our flow direction raster, and let's see what we got. Basically, I turned off the fill DEM too, so I can look at it on the nicely colored Central Utah DEM. And if we zoom in, we'll see that there's rivers flowing, tributary rivers flowing into trunk drainages. One thing I notice is that some of these rivers, like if we look right here, don't go far enough up the canyons, in my opinion. And so I could tune this a little bit more and basically say it doesn't take a full 1,000 to get a river, so that'll give me more rivers. So let's maybe just try 500. And it unfortunately lost what it was doing, so to change that back to it's not white, it's no color, and then black in this case. So now you can see my channels got a little longer, and that should be probably good enough. Does weird things when the channels go through the lake because it doesn't see any lake and the lake is flat. And it also doesn't, this modeling does not do alluvial fans. It does not do distributary drainage as well. It only does contributory systems. So take that for what it is. If you're in the alluvial fan environment, it's probably not going to be the greatest thing unless it's a very old dissected alluvial fan. But up here in Spanish Fork River, it will do a good job at finding out roughly where the channels are in the landscape. Okay, so the same thing has happened over here. Basically, if you click on this value symbology, we can change it from stretch to classified. It'll pop up. We can choose 2 as our classes, and then we can make the demarcations. So we can change that to what we said, 500. And so 500 is no color. And if you want to be different, we could make blue channels, and we'll turn off flow direction. And well, maybe we'll keep the fill on in this case. But if we zoom in, we'll see our blue channels all over the landscape. Okay, so that's how we go through first fill, flow direction, flow accumulation, and then classifying that flow accumulation, kind of tuning how many pixels does it take to make a channel in this landscape. And so I'll stop the video here.